Hi, today we are looking at section 4.3, which is the ambiguous case of the sine law. So if ambiguous case of a sine law is one of information that is given to us, could create 0, 1, or 2 triangles. And essentially in these situations, we're only using our sine law and our cosine law to solve them. So ambiguous case is when two possible triangles can be created with a given information. So it occurs when we're given two side lengths and an angle not contained by the sides. So for example, we have this angle here that's connected to a side length we do not know. We know this side, let's for example say that this is 15, and we could for example have a side that fits say here, which could for example be 10, but that same distance if rotated could also go here. So therefore we actually have two possible different triangles, because we would theoretically have either this triangle that I'm doing in purple, or we could also have this one that I'm doing in green. Now, there's also one other scenario, which is sometimes the distance isn't even long enough to reach this bottom part, so it can't create a triangle. So this is why it's ambiguous, because depending on the information we're given, we could have 0 triangles, we could have 1 triangle, or we could have 2 triangles. So there's some ways that we can go about determining how we have multiple triangles. So this first one, they give us an angle of 40 degrees. I'm just going to draw out our unknown side. We're measuring our side length off of that. And our angle. So we have angle A here, which is 40 degrees. Now its opposite side would be B. I'm just going to draw it like this because we don't know where exactly it's going. So our opposite it is side A, which is a distance of 5. Now this other side that we have here is going to be our side B, which is 10. So the first thing I would do is create a 90-degree triangle simply by going like this. Now we're going to calculate the height of this, because if this height is larger than this, then we can't have a triangle because this won't reach all the way down. Now, this would be our opposite side while we have our hypotenuse, so that means we would be using sine. So we know sine of our angle is equal to opposite over hypotenuse. We want to solve for our opposite side though, so we'd multiply both sides by our hypotenuse. So we have our hypotenuse times sine of our angle is equal to our opposite side. So I'd give us 10 sine of 40 is our opposite. So 10 sine of 40 gives us 6.43. So this distance here is 6.43. So this 5 is never going to reach the bottom. So since 6.43 was greater than 5, we have no triangles. because this just cannot reach that bottom part. Next, we'll do another one. So we've got, in this case, an angle of 40. So we have this here is 40. We're given that this side is 10. And this side, which once again, we don't exactly know where it goes. So I'll just draw it in like this, is 6.4. Now you'll notice I did the same length here and same angle here, simply to make it so we don't have to recalculate this height. We calculate that height using 10 and 40 here, so we know that height is 6.43, which will just round to 6.4. So because these are the exact same, we have one triangle. So I'll just call this my H for height. So since A, which is this side, equals our height, we have one triangle, which would be if it goes absolutely straight down, and that would be a 90-degree triangle, also known as a right triangle. The next one we have this is once again 40. Our B is still 10. This is A. That makes this side here, which once again, we don't know where exactly that is going. And that length is A, which is 8. Now, once again, I chose the same values here, so we know this height is 6.4. Now, 8 is larger than 6.4, so theoretically, it could continue to here, or it can also fit going back this way. So since our A is larger than H, we have two triangles. Okay, so next one. We have this is 40 degrees. This is 10, this is 12. So in this case, our H is still 6.4. However, we aren't going to have two triangles, even though our A is greater than H, but we can't have two triangles because this is so long. For 12, there's no way that will fit coming back this way because it's longer than this side. So we'll go back and modify that previous one. So since A is greater than H and A is also greater than our side length B, we have one triangle. So whenever this side that's opposite our angle is our largest side given, it's going to be only one triangle because there's no possible way this can fit going back this way. So if we go back here, we're also going to add that this side that's opposite our angle is smaller than this side. Okay, so we're going to look at an example. We have angle B is 23, angle A is, or sorry, side length A is 30, and side length B is 25, and we want to solve for side length C. Okay, so we're given an angle in its opposite side on one of our sides. So this is an ambiguous case, so we have to figure out how many triangles. So whenever we're doing that, I put my dashed line on the bottom for the side we do not know. Then draw in one side. Mark our angle. So our angle in this case was our B. So that's 23 degrees. Opposite it is side B. Which has a length of 25. And here we have side length A, which is 30. And then technically this side here would be C. Okay, so first thing we're going to do is find that height here. So doing so, we're using sine. So sine of our angle is equal to opposite over hypotenuse. Rearranging that, we get hypotenuse times sine of our angle gives us our opposite. So we have our hypotenuse in this case is 30. Sine of 23 gives us our opposite, which is our height. So that's 11.72. So since our B is larger than our H and our B is less than our A, we have two triangles. So that means that this one will continue this way, or that same distance can angle back this way. So we need to draw out each of those triangles separately so then we can solve them. So we have one triangle that angles back on itself. And we also have the triangle that extends out. So this is B, which makes this lowercase b, so B, lowercase b, A, which makes this A, which makes this A, and then this is C, and these are C. So our angle B's for both triangles are 23 degrees. Our side length B's for both triangles are 25. Our side length A's for both triangles are 30. Now we need to solve for side C. Now we don't have an angle across from that, and we don't have an angle between two sides, so we can't solve for side C right away. Instead, what we'll do is we'll solve for angle A. Now to do that, in both triangles, we have angle opposite, or sorry, beside opposite our angle, and then we've got an angle side pair. So I'll go sine of A is equal to, or sorry, sine of A over A is equal to sine of B over B. We want to get sine A on its own, so that's sine of A is equal to A sine of B over B. So we'll start substituting values in. So we've got sine of A is equal to side length A, which is 30, sine of 23 divided by 25. So that gives us 0.4688. Now we have A is equal to sine -1 of 0.4688. So we'll take the arc sine, and that gives us 28 degrees. Now we have two different angle A's, so we have to decide which one's 28. Now we can clearly see this angle is less than 90, while this one's greater than 90. This one's obtuse, while this one's acute, so this one would be 28 degrees. Now to figure out this one, we're utilizing information we picked up in section 4.1, in which we talked about how sine of our angle is the same as sine of 180 minus our angle. So therefore, to get this angle here, we're just going to go 180 minus our angle of 28, which gives us 152. Now we don't quite have enough information in either triangle yet to solve for side length C, but we have enough to get angle C in each triangle because we have two angles and we know all three add up to 180. So we know 180 is going to equal angle C plus 23 degrees plus 152 degrees. So we will subtract 23 and 152 from both sides. And we end up with an angle of 5 degrees. We'll do the same thing for this one. So we've got 180 degrees. It's equal to angle C plus 23 degrees plus 28 degrees. So we'll subtract 23 degrees and 28 degrees from both sides. And that gives us 129 degrees. It's equal to angle C. Now to solve for side length C, we can use cosine law or sine law. I tend to use sine law, but you could just as easily use cosine law. So if I'm solving for this side here, that would be C over sine C equals, I'd probably go back to our original value, so B over sine of B. We want to rearrange to get C on its own, so we've got C equals B sine of C over sine of B. Now we can essentially use this equation for both of these. So for this one, we have C is equal to side length B, which is 25, sine of angle C, which was 5 degrees, over sine of angle B, which was 23 degrees. Which gives us 5.6. So side length C here is 5.6. And then if we do the same thing for this triangle, we have C is equal to side length B, which is 25, sine of angle C, which is 129, over sine of angle B, which was 23. And that should give us a side length of 49.7. So we have solved both these triangles. Okay, so we'll look at another example. This one we are given an angle of 28 degrees, its opposite side of 32, and another side which is 34. We want to solve for side length B. So this is ambiguous case because we have an angle, its opposite side and 1/side. So we will draw out this triangle to try to determine how many triangles it is. So we're given A, which is 28 degrees. Opposite is side A, which has a length of 32. This side is 34. And we want to first figure out our height. So doing that was utilizing sine. So we had sine was opposite over hypotenuse. We want to solve for our opposite. So we have hypotenuse times sine of our angle gives us our opposite side. So 34 sine of 28 gives us our opposite. So we have a height of 16. So since this is larger than this and less than this, we have two triangles. So I will just quickly draw out both those triangles. We've got the triangle that angles back on itself. We also have the triangle that looks like this. So we'll label our sides and angles. Put in the values that we know. So we know A is 28 degrees. Our C is 34. And our side length A is 32. So first thing I'll solve for again is this angle here. So that'll be angle C. So with these, that would be sine of C over C equals, we have our values for A, so sine of A over A. Rearranging that gives us sine of angle C is equal to side length C times sine of angle A over side length A. We'll fill in our values. So we have sine of C is equal to side length C, which is 34, sine of angle A, which is 28, divided by side length A, which is 32. So that gives us sine of C is equal to 0.4988. We'll use arc sine, which shows up on your calculator, sine -1. I have 0.4988. And that gives us 30 degrees. Now, we can tell this is obtuse, so that's not 30 degrees. This one's acute, so this one would be 30. To get this side here, that would be 180 minus 30, so that's 150 degrees. Now to get our missing angle here, we can just do 180 minus 28 minus 150, which gives us 2 degrees. For this one, we have 180 minus 28 minus 30, which gives us 122 degrees. Next, we'll solve for side length B, so I'll use sine law. So we have side length B over sine of B equals, we have our values for A right from the start, so I'll use them. So A over sine A. Rearranging that gives us B equals side length A times sine of angle B over sine of angle A. We'll fill in our information. So we've got side length A, which is 32, sine of angle B, which for this first one is 2, over sine of angle A, which is 28. So our B value for this first one is 2.4. For the second one, we're doing essentially the same equation, but our angle B is different. So we've got A is 32, sine of 122 divided by sine of 28. Which gives us 57.8.